In this video, we're going to pick up a few of the things that we missed in our review. So we're going to do problem 3 and problem 10. So problem 3, we had it done right. There was a piece that I was just missing of why it converged. So the first thing was we were supposed to find the nth term. So to find the nth term, remember it's based off of the term number. So this is term 1, term 2, term 3, term 4, term 5. So I want to see if I can find a pattern. It looks like the numerator is increasing by 1. So it looks like it's n plus 1, because if I put 1 plus 1 would be 2. 2 plus 1 would be 3. 3 plus 1 would be 4. And then it looks like the denominator is squaring the term number, so it would be n squared. So that would be the sum as n, or from 1 to infinity. The thing that we know about that, though, is that because it's a sequence, it's going to eventually get to an end, okay? Whereas a series goes kind of on forever, it looks like it's getting to a limit, so therefore this will converge. This isn't something that we're going to put on the test this week, but it's because we've got a sequence that when we do the limit as n approaches infinity of this, which I know I could do L'Hopital on, which would be the limit as n approaches infinity of 1 over n, that's going to equal 0. So in this case, because we've got a sequence, that will converge versus a series. All right, so let's look at number 10 here. Let me erase. All right, so the problem with number 10 is it says limit comparison test. So we tried to do limit comparison test. It really should have said ratio test, which we didn't have an example of ratio test anywhere. It works completely by the ratio test. So remember the ratio test, we're going to have to substitute in n plus 1. So we're going to do the limit as n approaches infinity of 3 to the n plus 1 over n plus 1 cubed times, or divided by the original or multiplied by the reciprocal. And then I think technically it's absolute value. So then you've got the limit as n approaches infinity of, I'm going to rearrange and rewrite a little bit. It's 3 to the n times 3. N cubed is going to stay there. I'm going to bring the 3 to the n here and n plus 1 cubed there. I know these are going to cancel. This here, when I take the limit as we approach infinity, has a coefficient of 1. So it's just going to be 1. The limit there is 3. So I get 3 times 1, which is 3. And we know that that is, let me use a different color, greater than, I think it has to be greater than 1. And if I go look at my ratio test, when I am greater than 1, I diverge. So diverges by ratio test.